In this section, I'll tell you a little bit more about evaluating the quality of a search engine. There are many measures for the quality of a search engine. There are technical ones such as how fast does it index and how fast does it search. We can look at things like the expressiveness of the query language, whether we're able to express complex informational needs with things like phrase queries, negations, disjunctions. People have other desires like having an uncluttered UI and a system that doesn't cost a lot to use. All of these are measures that are measurable, that we can quantify them and we can get some kind of score of what is their goodness. But in practice, all of those measures, while important, tend to be dominated by another measure of user happiness, that is the user happy in using this search engine? And speed of response and size of the index are certainly factors, but by themselves, blindingly fast, useless answers won't make a user happy. So a huge part of user happiness is, are the results returned results that they want? And so that's the metric of relevance of results to a user's information need. I mentioned this right at the beginning, but just to reiterate once more, when evaluating an IR system, that we evaluate with respect to an information need. So an information need is translated into a query, and that's what the IR system actually runs. But relevance is assessed relative to the information need, not the query. So for example, if the information need is the person is looking for information on whether drinking red wine is more effective than white wine, for reducing your risk of heart attacks, they'll come up with some query. For example, it might be wine red, white heart attack effective, and that'll be submitted to a search engine. And in evaluating the effectiveness of the search engine and returning relevant results, we're not asking, are the results that the search engine returns documents that simply have those words on the page? Rather, we're saying, do these documents address the user's information need? Okay, well, how can we go about doing that? Well, if the search engine returns a set of results, well, then what we can do for evaluation is, if we start off with three things, if we have some benchmark collection of documents that we can use for evaluation, and we have some benchmark set of queries, which are in some sense representative of information needs of interest, and then we've gathered this third thing, which is assessor judgments of whether particular documents are relevant to particular queries. Commonly in practice, this can't be assembled exhaustively, certainly not if the document collection is large, but at least for a particular set of documents that are returned by particular search engines, we can get the assessor to judge whether those documents are relevant to the queries. Well, if we have a results set, with just these three things, we're in business, because we can use exactly the same measures that we looked at previously, precision, recall, and the F measure that combines them. And these are suitable good measures for exactly the same reason that they are good measures for when we're talking about things like named entity recognition, that normally only a few documents will be relevant to a particular query, and so we can measure that much better by looking at these measures of precision and recall. But what if we've now moved on to a search engine that returns ranked results? We can't just totally straightforwardly use these measures of precision, recall, and F measure, because the system can return any number of results. In fact, the number it returns normally depends on how often we keep on clicking asking for more. But if we sort of look at any initial subset of the results, we can then work out the precision and recall for that subset, and then by putting them together we can come up with a precision recall curve. Let's look at how that works. So here are the first 10 results for a search engine, where we've labeled each result as either relevant or not relevant according to an assessor's judgment. And so then we can take any initial subsequence of these documents and work out a recall and precision. So for the first document, the system got it right. It's a relevant document. And let's assume that overall there are 10 relevant documents in the collection. So it's gotten 1 out of the 10 relevant documents, and so its recall is 0.1. And well, since that document was relevant, the system was right on the first answer. Its precision is 1 at this point. Well, the next document was not relevant, so the recall of the first 2 documents, we're down to here now, is 0.1, and the precision is now 0.5. Another not relevant document, so the precision is, the recall is still 0.1, and the precision is now dropped to 0.33. Then if we look at the set of the top 4 documents, we've now found 2 of the 10 relevant ones, so recall is 0.2, and our precision has gone back up again to 0.5. The 5th one is also relevant, so now our recall is up to 0.3, and our recall is up to 3 out of 5, 0.6. And we can keep on going down. Maybe you guys could work out what some of these entries are down here. The other measure I want to mention, one of the most used recent measures, is mean average precision. If we look at the ranked retrieval results ordered this way to give me a bit more room, and so the first document returned is relevant, the second one is not relevant, say, the third one is not relevant, then a relevant one, and another relevant one, not relevant, relevant, relevant. Let's say those are our top 8 results. What you're doing for mean average precision, first of all, you're working out an average precision for one query. And so the way you do that is by saying, let's work out the precision at each point that a relevant document is returned, because that's when you're increasing recall. So here the precision is 1. Here there are now 4 documents, so the precision is 1/2. Here there are 5 documents, so the precision is 0.6. Here there are 7 documents, of which 4 of them are relevant, so this is around 0.58. You guys can correct my arithmetic. Here we now have 8 documents, of which 5 are relevant, and that's 0.625. And then what we're doing to work out the mean average precision is we're kind of keeping on calculating those numbers. In practice, normally they aren't calculated exhaustively, but they're calculated up to some point, let's say 100, and then you're calculating an average function of all those numbers. And that's then the average precision for one query. You then calculate the same average precision for all the other queries in your benchmark query collection, and you again take the average of that, and that then gives you mean average precision. So in particular, this is what's referred to as macro averaging. It's each query that counts equally in the calculation of mean average precision. So this is a good measure that evaluates to some extent precision at different recall levels, while still being weighted most to what the precision is like for the top few returned documents. And then at the level of across different queries, it's giving equal weight to different queries, which tends to be a useful thing to do because you're always interested in how systems work on queries of rare terms as well as queries of common terms. So this is a pretty good measure to think about using for evaluating information retrieval systems. Okay, there's even more methods that I could talk about, but that's probably a good sense of how to go about evaluating the performance of a ranked retrieval system.